The 300 Alzheimer's drug trials have failed so far. The failure rate is almost 100%. Promising Alzheimer's drug Leqembi gets green light in US. New class of Alzheimer drugs shows promise. Donanenmab could slow Alzheimer's by 35%. Leqembi versus Donanenmab is the breakthrough for Alzheimer's disease just around the corner. The views expressed in this podcast are my own thoughts and opinions. They do not reflect the values of my employers. Hello, welcome to the Crossover Connections with Jack Wang Podcast. My name is Jack. I'm an Australian scientist and college professor at a university, and this is a podcast that talks about science, technology, productivity, and how all of this intersects to inform us about the jobs of the future. This episode is all about the promise and potential of new drugs that are designed to treat Alzheimer's disease, a neurodegenerative form of dementia, which really has very sad and tragic impacts on people's lives as they age. They will lose their cognitive ability and memory and ability to connect with their loved ones. And this is something that has been invested with billions and billions of dollars from big pharma and research all across the globe. And to date, there's not been that much progress that's been made in terms of treating Alzheimer's. Percentage of drug trials that have gone through to succeed and show promise of improved cognitive ability in Alzheimer's patients is very close to 0%. And whenever we look at headlines about another breakthrough, my first instinct is not hope, not because I'm cynical about it, but just because I know that the likelihood of success is very minimal when it comes to any kind of new disease therapy. To understand how all of these things might play into the future of Alzheimer's disease treatment, let's do a deep dive into the headlines today and try and explore exactly how these drugs work, whether they have a real shot at improving Alzheimer's therapy, how do you know if you or a loved one may be at risk of Alzheimer's, and lastly, of course, how this ties into the jobs of the future. Let's go to a website very well renowned for its dissemination of good public health information on this disease, which is Dementia Australia. Anyone can develop Alzheimer's. Usually we see it progress further and more aggressively the older you get, but certainly anyone is at risk of Alzheimer's. And from what we know in the literature, physical inactivity, lack of mental exercise, as well as some general health risks around smoking, obesity, diabetes, cholesterol, and high blood pressure, this all may increase your risk or your propensity of risk for Alzheimer's disease. And the signs and symptoms pretty much revolve around neurocognitive degeneration, short-term memory loss, repeatedly saying the same things, having vagueness in everyday conversation, losing the ability to plan or problem solve or do routine tasks in a slower way, and also some language difficulty, disorientation. And this is the big one for family members if there is a change in behavior, personality, or mood. The problem with all of this is that diagnosing Alzheimer's disease, as you can tell from those list of symptoms, is quite imprecise. From a behavioral perspective, people could be going through a range of different experiences or maybe have some other mental health issues, and they will have all of these, if not most of these symptoms. And that's why, according to this website, there is no single test currently available to diagnose Alzheimer's disease, and it is almost a disease of exclusion once you've excluded all of the other possibilities that are associated with those signs and symptoms. And the physician normally needs to take medical history, physical exam, blood and urine tests, and in some cases the cerebral spinal fluid, as well as psychiatric and neuropsychological tests and brain scans if it comes to that. The brain scans and the blood tests and the urine tests, they're more down my field, where we look at a very specific biomarker or we're looking for a very clear lesion or a plaque on the brain scans. The way that people pick this up in their everyday lives is through the behavioral changes, the family members and loved ones that are best placed to notice those changes. You need to be in careful consultation with your GP to really manage this going forward. People will lose mobility as well and become dependent, requiring extensive care. And at that point, they may have lost memory or connection with their immediate loved ones. So they're in a constant state of distress. It's a very sad situation and also very severe disease progression, hence the billions and billions of dollars of investment in trying to find new treatments for Alzheimer's. There are all of these exposés, these long form articles about how slow the progress in Alzheimer's research really is. Now, as scientists, we don't think of it as slow, but from the general public's perception, we've known about Alzheimer's for a very long time. We all probably know someone in our immediate family or almost immediate family with Alzheimer's disease. Notion that big pharma is this all-powerful entity that can solve everything. You would have thought that the payoff for curing something like Alzheimer's disease is so incredibly high that someone would have already come out of the woodwork with a cure. As this article from the ABC goes into it, they interview a number of Alzheimer's disease researchers. This is a very dispiriting state of the field back in 2020. 2 drugs that were being investigated at that time would not stop memory loss and cognitive decline in people. 300 Alzheimer's drug trials have failed so far. Everyone thinks the next experiment is the one that will have the breakthrough. Otherwise, how can you have any optimism to keep continuing this kind of work? This trial, like 300 drug trials before it, also failed and were scientists on the wrong track all along. The article makes reference of something called the Amyloid Hypothesis, which is the hypothesis in Alzheimer's research, this buildup of the protein amyloid in the brain that is one of the early signs that Alzheimer's is on its way. And as amyloid builds up, it appears as plaques in the brain. As the hypothesis goes, as amyloid builds up in the brain, they form these plaques that would then interfere with the brain communication and then destroy memory function as well as other parts of the brain functionality as well. So this was the amyloid hypothesis, and many of the therapies were focused on trying to slow down the production of amyloid in the brain. The problem, of course, is that many of these drugs would not slow cognitive deterioration. All of the efforts that were invested into these anti-amyloid drugs that would prevent or slow down amyloid from being built up in the brain, when you get negative trial after negative trial, it does give you pause. But in spite of this negativity, there are some researchers who were more optimistic, convinced that they were on the right path, and to move forward with a multi-targeted approach, not just focusing on anti-amyloid therapies. The other characteristic protein involved in Alzheimer's is tau, T-A-U, that go hand in hand with memory and cognitive decline, and the combination of the amyloid plaques as well as the tau protein. These two are the hallmarks of Alzheimer's disease from a clinically diagnostic perspective. In 2020, there wasn't huge promise of a breakthrough. Fast forward now to 2023, and we have not just one, but we have 2 headlines in quick succession all around new drugs against Alzheimer's disease. And what's really interesting is that both of these new drugs, Leqembi as well as Donanenmab, they are actually anti-amyloid therapies as well. So people who thought the amyloid hypothesis was flawed all of a sudden have 2 new drugs that maybe counteract their line of thinking. Right now, the US FDA, the Food and Drug Administration, endorsed this drug for IV therapy in patients with mild dementia or other symptoms caused by early Alzheimer's disease. It's the first medicine that's convincingly shown to modestly slow the cognitive decline caused by Alzheimer's. And in Australia, our version of the FDA, the TGA, has accepted and convinced evaluation for the use of Leqembi in Australia. And Leqembi does have a less known clinical name, Lecanemab. Leqembi is priced at US $26,500 for a year's supply of IVs that you administer every 2 weeks. This then being plugged into our National Health Service equivalent here in Australia, Medicare, which cares for 60 million seniors, has a large percentage of them at risk of Alzheimer's or certainly curious about this drug and might want to sign up for it. If we have to bankroll that from our tax dollars, $26,500 for 1 year's supply, that is going to be a lot of investment for a drug that we're not sure is convincing in terms of its ability to treat Alzheimer's disease. The drug in people with early or mild disease, using a scale measuring memory, thinking of other basic skills, after 18 months, so it's not a one-off, it's not like a pill or a syringe and you're fixed, you're cured. You got to undergo this IV therapy every 2 weeks for 18 months. Those who receive Leqembi, as opposed to a placebo, their memory declined more slowly. How much more slowly? A difference of less than half the point on the memory scale. And some Alzheimer's experts say that the delay is likely too subtle for the patients or their families to notice. But that's a very subjective call. A half a point on a memory scale could translate to additional years of contact with loved ones. So it's nothing to be scoffed at, but this is not going to be a revolution in terms of a cure overnight for Alzheimer's disease. There is promise that this anti-amyloid drug, probably for the first time, has an impact in slowing down memory decline in Alzheimer's disease. The other drug is also an anti-amyloid drug. It is called Donanenmab, and this is actually pretty tricky to pronounce. It rhymes with doner kebab, Donanenmab, and the mab at the end of it, the MAB, is a simplification of monoclonal antibody. It's an antibody that is very specific, that binds to and recognizes one thing, and that one thing in this case is amyloid. Both Donanenmab and Leqembi, or lecanemab target the amyloid protein, which forms the plaques in the brains of Alzheimer's patients, they will have the same downstream impact to potentially slow down the formation of those plaques and therefore slow down the progression of Alzheimer's disease. What does this study show about donanemab? It could slow Alzheimer's disease progression by 35% in patients. That's quite a lot. 35% is dramatic. And it's similar to its predecessor, lecanemab. Lecanemab, or Leqembi, has been through the trial a little earlier and it already has FDA approval. 22% slowdown in the disease progress after 18 months. So again, this is not an overnight cure. It's after 18 months of therapy. How does the new drug work? Donanemab is a monoclonal antibody designed to bind to amyloid and clear the brain of the amyloid plaques. And it's the interplay between these amyloid plaques, as well as the other protein called tau, that we believe to be responsible for Alzheimer's disease. And this is an anti-amyloid therapy. And the people who were in the study, they were all in the early stages of Alzheimer's and aged between 60 and 85. At the 12-month mark, 47% had no evidence of amyloid plaques. Amyloid plaques are only part of the diagnostic picture. Presence of the plaque does not confirm 100% that you will get Alzheimer's disease. But nevertheless, this is very exciting therapy news. Patients also did not need indefinite treatment. The idea is that injections are able to persist maybe for 6 months, maybe for a year, and after that you could stop taking the therapy. That's also very exciting. You don't want to have to go to take these intravenous IV drips every single day, but still not very convenient in terms of administering this ongoing treatment and ongoing therapy. 6 to 7 billion Australian dollars per year to treat and care for Alzheimer's and also improve the infrastructure so that the brain scans that you would need to confirm the diagnosis were more readily available, and that GPs were very well trained on when to refer and when not to refer for an additional scan. And unfortunately, there's going to be quite a delay that we have to overcome in when people first experience symptoms to when they then get the right diagnosis for Alzheimer's. That delay could really slow down their access to this therapy, which again works best in early onset cases of Alzheimer's. I'm really interested in the science side of things, exactly how this drug works and why this drug has worked when other previous anti-amyloid therapies haven't worked. Science is probably one of the two biggest journals in our field of molecular biosciences, the other being Nature. Scientific news on the science website is probably pretty well vetted and pretty well researched. Alzheimer's trial shows clear benefit, but also significant risk, and the safety is going to be brain bleeding and swelling. On the heels of the historic full US approval of the Alzheimer's therapy lecanemab, that's Leqembi, a similarly acting drug, donanemab, has demonstrated effectiveness against the brain disorder, but with greater risk. Donanenmab mops up a protein called beta amyloid, which accumulates in the brain. Donanenmab and lecanemab modestly slow the cognitive decline that marks Alzheimer's, making the first amyloid targeting drugs to clearly demonstrate success in advanced clinical trials. But here's the kicker: both donanemab and lecanemab come with risk of serious or even fatal brain swelling and bleeding, and the positive trial results would likely not be questioned by patients, clinicians, or payers if these antibodies were low risk, inexpensive, and simple to administer, but they are none of these. It involves intravenous infusion every 4 weeks for 18 months. At least that's what happened in the trial. In the actual real world use, it could be less frequent, or maybe it has to be more frequent, up the dosage or lower the dosage. Just unclear how that's going to work. Intravenous infusion is not something you can do at home by yourself. You need to go to a clinic for them to do it for you. Alzheimer's has two hallmarks, one being the beta amyloid plaques and the other being the presence of the tau protein. And the people in these trials were split into a group which had the amyloid plaques versus those that had a lot of these tangles that are filled with the tau protein. And the patients with the beta amyloid plaques but not much of the tau protein had the best improvement. They had a 35 to 36% slowdown in cognitive decline. If you had high tau, the tau protein in these tangles in your brain, either a 21% improvement in cognitive function compared to a placebo or no difference at all. So it would appear that the tau protein is a marker of a different stage of Alzheimer's, after which drugs like this may be not so effective after all. And that kind of makes sense given that these drugs are targeting amyloid. They're not targeting the tau protein. If you don't hit the Alzheimer's disease early enough with these anti-amyloid therapies and the tau protein is allowed to accumulate, the effect does not override the overall presence of these tau-filled tangles. That's what this data seems to suggest. Well, people need to keep taking these anti-amyloid antibodies forever or indefinitely because of cost, side effects, and the inconvenience and discomfort of infusions. The trial experimented with discontinuing Donanenmab if a PET scan 6 or 12 months into treatment showed clearance of these plaques. Perhaps after 6 months or 12 months of infusion, you can go back for a regular brain scan every 6 or 12 months. And if you're clear, you wouldn't need to go back on these infusions. That's a functional model. That also makes it a little bit cheaper. These antibodies come with a chance of brain swelling or bleeding, known as amyloid-related imaging abnormalities or ARIA, and these can be fatal. Out of the patients who went on Donanenmab, they had brain swelling, and a quarter of them had symptoms which included headaches, and 3 people died from brain swelling or bleeding. So this is not completely risk-free. Leqembi, it is a lot safer based on these same measurements. In the Donanenmab trial, 37% of the people getting the antibody developed these amyloid-related imaging abnormalities or ARIA, whereas in the Leqembi trial, only 21% of patients developed these imaging abnormalities. 12.6% had brain swelling. There were no deaths related to the drug and related to Leqembi. So it appears that Leqembi is a little bit more safe than Donanenmab, but also I think the impact it has on memory decline is a bit more subtle than Donanenmab as well. But these are a pool of a couple of thousand people. When you expand the scope of these trials to a much larger pool of people, you're likely going to see even more side effects. So you have to be aware of the potential safety risks involved. But all of that is worth it if your loved one at risk of Alzheimer's disease has a few more years to remain connected to their family and enjoy the memories of their loved ones and being present in the moment. Let's come back again to the diagnostic part of Alzheimer's and how we as family members or loved ones could help those who are in our family who may be at risk. The problem though is there is no definitive test for any form of dementia. There's not one gold standard that we can just use and we'll know that they have Alzheimer's. You can run blood tests to exclude other problems such as anemia, infection, or electrolyte imbalance, and also doing some urine tests to investigate infection. Outside of doing blood tests and PET scans and CSF scans, cerebrospinal fluid testing to check for the presence of these amyloid plaques or the tau tangles, what we can very easily access is going to be these cognitive tests where you go to a doctor and they administered this cognitive test to test your memory and learning abilities. Within a pretty short amount of time, you will have a baseline for your cognitive abilities. And if you do this every year, you'll know if you're declining over time. I am not licensed to give this kind of test, so I'm not going to administer one over the podcast, but I will say that the one that is the most accessible is the Mini Mental Status Examination, MMSE. It takes around 5 minutes to complete, and it is the most common test for the screening of dementia. So again, this is the Mini Mental Status Examination, the MMSE. You can very easily Google it to see the types of questions that are there. Let's see how I do on this Alzheimer's memory test. Again, the scoring of this is completely arbitrary now because I'm not licensed to give this, but I can try and attempt these questions. First question, orientation. What is the year? 2023. What is the season? In Australia, we're in winter. What is the date, day, and month? I believe right now we're in July and we're in 2023. The exact date, I'm not sure. So maybe I don't score full marks for this. Apparently I get a score that's maximum 5. So maybe I'll get a 4 out of 5. Don't know the exact date. Where are we? The state, we're in Queensland. What's the town? I'm in Brisbane. What's the hospital? I'm not in a hospital right now. What's the floor of the hospital? I'm not in a hospital. If my home was a hospital, I'm on the ground floor. Location and time, orientation, that's again a score out of maximum of 5. I guess I can give myself a maximum of 5. I know where I am and I know where I'm situated. Next one is a little trickier to administer by myself, so I might administer it to you. The key here is I have to name 3 objects. I'm going to take a second to say each of them, and they're going to ask you what these 3 objects are. The 3 objects are a remote control, a pocket knife, some earphones. I'm supposed to give you 1 point for each correct answer here. So the 3 objects were, if you were playing along at home, a remote control, a pocket knife, some earphones. You may get all 3 right on your first go. You basically get an unlimited number of goes until you get all 3 objects right. Again, the higher the trials that it takes for you to get those 3 objects, the lower your score. The next one, serial 7's attention and calculation. You start at 100 and you keep subtracting 7. And you do that 5 times. Unprepped, unrehearsed, 100 minus 7, 93. 93 minus 7, stumped already. 93 minus 7 is 86. 86 minus 7 is 79. 79 minus 7 is 72. 72 minus 7 is 65. For those of you listening on the podcast, you can double check me and leave a comment here to let me know if I screwed any of those calculations up, because if I got the first 5 answers right, subtracting 7 from 100 repeatedly 5 times, I get a maximum score of 5. The alternative is to spell a word backwards, and the word here is the word world. So spelling world backwards. I'm going to try this again without looking at the word on screen. DLROW. Hopefully I got that right. Again, I'm not licensed to administer this to anyone, let alone myself. I'm just doing this out of curiosity. And at this stage of the mini mental state exam, you ask the person to recall what were the 3 objects I named earlier. And this time, it's not a number of trials game. It's not they get an unlimited number of trials. It's just yes or no. Do you remember what the 3 objects are? You get a point for every object you get correct. And for those of you playing at home, the 3 objects I named were a remote control, a pocket knife, and a pair of earphones. 3 points for you if you got that right in this recall part of the mini mental state exam. The rest of the mini mental state exam doesn't really work over this audio visual medium. It involves the person writing a sentence and seeing if that sentence makes sense grammatically, logically, structure-wise, and then following a command where you're folding paper and putting it somewhere, as well as closing your eyes, and then copying a design which involves 2 pentagons that are overlapping, and depending on your total score, that is your benchmark for mini mental state exam. One reading doesn't mean anything. It's how you progress over time. And maybe this time next year, if you do this again, compare your score and test if your mental capabilities are staying the same, plateauing, getting better, maybe they're getting better, or if they're declining over time. This is clearly something that is really variable and has lots of different factors that will influence your cognitive ability. From Dementia Australia, it gave you some risk factors for the people who are more at risk of Alzheimer's: physical inactivity, lack of mental exercise, smoking, obesity, diabetes, high cholesterol, high blood pressure. But there are of course other risks that may put you firmly in the crosshairs of something like dementia or Alzheimer's. And this is a very tragic article. The first case of dementia linked to repetitive brain trauma in a female athlete. Repetitive brain trauma is very famous in the sporting world. For those of you who watch American football, the NFL in America, chronic traumatic encephalopathy, CTE. This happens a lot where the people playing American football are banging their heads all the time. Many of those athletes retire and do scans and find lesions in the brain that cause dramatic behavioral and cognitive changes in these athletes. And this article from The Conversation highlights there was a diagnosis on the brain of an Australian athlete, Heather Anderson, who plays in the women's AFL, our own version of football in Australia. And unfortunately, they died last November. And when they donated the brain to the Australian Sports Brain Bank, it was found that her death was linked to repeated trauma, likely from playing the sport, and it is CTE. So repeated contact to the head does cause brain damage and does cause degeneration of the neurons, and is certainly a risk factor for dementia and Alzheimer's. But the problem with CTE is that you can only diagnose it once you've passed away. It can only be diagnosed post-mortem. We don't have any great biomarkers that can detect it early, but hopefully there's overlap between CTE at a biological level as well as Alzheimer's, and that many of the drugs that people are finding used to treat Alzheimer's might find its way over into helping these people who may be at risk of CTE and brain trauma in sports. On that note of uncertainty and trepidation, that brings me to Whose Job Is It Anyway? Our recurring podcast segment that explores the headlines in employability and finding jobs of the future. Smart drugs. Drugs that are designed, or at least advertised, to help boost your brain function to give you a competitive edge either in your work or your study. These smart drugs make you worse at studying complex problems. People in the financial services on Wall Street or medical students, they use smart drugs to enhance their cognitive performance. And one example is Ritalin, which has been effectively used to treat ADHD, attention deficit hyperactivity disorder. Even for people without ADHD, they have reported using these smart drugs like Ritalin make them feel like they're better at doing their jobs, and they're taking these supplements to give themselves an edge in the modern workplace. Brain chemistry is still a huge black box. And messing with brain chemistry deliberately is really dangerous and risky behavior, because that list of risk factors for Alzheimer's, for dementia, for even CTE, it is very incomplete. So I would not recommend this. But what about from an effectiveness perspective? Will taking Ritalin actually make you better at doing your job? Well, this new study did study 3 common smart drugs and found that they had effect on cognitive effort and frantic activity. So that might give you the illusion that you're performing more highly. In general, the drugs made these people's output worse. The drugs they've looked at: methylphenidate, dextroamphetamine, and modafinil. And the whole idea of these drugs is to increase the amount of the neurotransmitter dopamine in the brain. And these drugs are known for producing changes in attention, motivation, and wakefulness, and they have been proved to be a safe and effective part of ADHD treatment. The earlier studies into these drugs looked at simple tasks like memorizing and simple spatial moves. But memorizing, as I tell all my students, is not going to be enough for you when you graduate. It's actually about high order complex problem solving skills in any modern workplace. And it's not just, can you repeat all this information to me? That's pointless. You can just go Google the information. It's about organizing the information, synthesizing it, summarizing the main trends that you feel the data is telling you, and making some predictions about the future of this data. And this study used something called the knapsack problem to simulate a more complex, high-order problem. Participants faced a computer game, which asked them to imagine they have a bag that can hold a certain amount of weight. The game then presented 10 or 12 different items, each of which had a weight and a dollar value. And the goal was to put the maximum value in the bag without going over the weight limit. Get a dollar value for each of these things, and you try and shove as much into this bag as possible without going over the weight limit. But you see, that's a more complex task than just memorize all the items and repeat after me. That's not a very useful workplace task. But it is a more useful workplace task to rank a list of items in an inventory and tell your boss which one's going to sell the best next quarter and make that prediction. The participants had 4 minutes to try different combinations of items and had to complete 8 of these problems at 5 different levels of difficulty, each presented twice. After taking these smart drugs, not only did these patients do the same as the patients or trial participants who didn't take the drugs, they took much longer to complete the problems. So these smart drugs made them worse at these high order problem-solving skills. They spent significantly more time and tried significantly more combinations of items before submitting their selections. And they did worse. On average, they found the optimal combination less often. They spent a lot more effort, but their productivity suffered significantly. Cognition is a complex thing, and there is no shortcut. We've been spending decades trying to find drugs to slow down the deterioration of Alzheimer's disease, and only now have we very recently found 2 drugs, Leqembi and Donanemab. So if you are trying to shortcut and trying to hack your brain, like in the movie Limitless, so far it is very dangerous to do so. We don't recommend you do so, and also you might have negative consequences on your productivity in the short term. And to finish this episode of the podcast, The Connect, our recurring segment where we revisit old issues touched on in past episodes of the podcast, mental health apps and what they're doing with our data. And this is an episode that had comments from Progenitor's Soul. This is a very detailed and insightful comment. Comes courtesy of a psychologist who's based in Brazil. Apparently in Brazil, the perception is that the availability of professionals is not the bottleneck. We have a lot of them, and there's always been a steady amount of new students and professionals entering the career path. It's actually a different problem in Brazil as it relates to mental health. The perception of elitism. It is not accessible to everyone. It can cost $100 to $200 per session in different countries, and that can be prohibitively expensive. And certainly in Australia, Medicare does subsidize it to a large portion. If it's so expensive in Brazil, I can understand that that would very much be a bottleneck. Thank you so much for sharing from your profession. It's great to hear from mental health professionals. Keep doing the great work that you're doing. Thank you again for connecting with me on the episode Progenitor's Soul. You can find all of our past podcast episodes on Apple Podcasts, Spotify, or Google Podcasts. You can find the full video episodes as well as clips on the YouTube channel Biolab Collective with Jack Wang. I'm Jack. Hope to connect you again next time around.